Well, welcome everybody. It's good to be together. So I'm Jim Sherwood. I'm the Dean of the Francis College of Engineering, and it's really nice to be here together with you here this evening. So this is the 8th annual Difference Makers for the Francis College of Engineering. And this competition was designed to promote and to recognize the innovation within the college. And I was very impressed as I went around this evening and listened to the various project presentations. All of you are amazing with your creativity. So we received 20 applications this year. There were, I believe, 12 that were presented this evening. And tonight, what you're going to hear now in this program is from the top 5 teams based on the preliminary judges from the presentations that you gave to those teams. And each team is going to be competing, well, in total, you're competing for prizes, cash money up to $5,500. And each team is going to have 5 minutes to present their project idea to the judges up here, and I'll introduce the judges in a moment. And there'll be 5 minutes for the judges to do Q&A with you. So basically, you get to do an encore performance of what you already did with the preliminary judges. So after all 5 teams have presented, we'll have a 30-minute intermission while the judges deliberate over the first, second, and third place winners. And around 8:30, the judges will return and the winners will be announced. So we know from the previous competitions that these teams are going to go on to do amazing things, as we have right here with Raja. She's a great example for the Difference Maker program. Her team won this competition, or participated in this competition. I don't know exactly where you came out, Raja, when you competed, but you did very well. And they have a business here in Lowell. She just informed me that they have 17 employees, and it says here that you have $1 million in sales, but you made it sound like it was multi-million dollars in sales. So
I'll take the 5th, but definitely multi.
So we don't want to undersell it here. And you may have seen them featured on various news stations like WZVB and Fox 25 News for saving lives for their Invisaware product. So they recently struck up a partnership with ADT, a very familiar name in home security, and recently had something on QVC. So wonder how many times on QVC? Once or twice? Very good. So another recent winner of the Difference Makers Idea Challenge in this competition was Ambulatory Innovations, where they pitched and won regional competitions against Harvard, MIT, BU in Northeastern. And now they're working with the Nerve Center to test out their products. So what these young ladies have developed is a portable system for physical therapists to take to patients' homes, where they can set up different terrains. So they just have these little 1-foot by 1-foot tiles, and they have different surface conditions on them. So what they can do is they can set up an obstacle course basically for the patient and see how well the patient can navigate it. So I'd like to express some thank yous right now. I'd like to thank everyone who joined us this evening. But before we get started, I'd like to recognize all the Difference Maker faculty fellows who act as ambassadors for the Difference Maker program within their colleges and departments. So these faculty members help mentor student teams and prepare for the competition like this. So a special thank you to the Francis College of Engineering, faculty fellows Carter Keogh and Kalila Walkowitz. Carter and Keogh, I know you're here. Will you stand up? Oh. You got to stand up. So I just want to add a little bit more about these two young ladies. So I had the pleasure of hiring them in the past year. So they both started last fall. And yeah, after I got them to sign the contract, then I said, I'd like to have another conversation with you. So I have two activities that really need somebody like you. You really impressed me during the interviewing process. So DifferenceMakers needs a fellow, and the Society of Women Engineers needs a faculty mentor. And I think each of you would be good for either one of these positions, but I don't want to overload you. I want you to just pick one. And so we left the meeting and said, think about it, come back a week later, and I kind of already knew what the answer was going to be. They both said, we want to do both things. So, and they are doing amazing at both of those and still accelerating at what they're doing in the classroom. I'd also like to thank DifferenceMaker team, Holly Lalos, the director. So Holly, where are you hiding? Okay. She's probably over there eating the cookies that we left. That's and David Vadalero, a RISC fellow, for collaborating with the Francis College of Engineering. David, are you here? Okay, very good. Also, Sally Washburn, who is the Senior Director of Development. Sally recently had some surgery, so she's not able to join us today, but I heard from Karen back there that Sally is doing great, and you probably had to keep her away from here this evening, or she would have been here. So she needs to keep recuperating. And Derek Berger, Associate Vice Chancellor for Development for, well, I want to thank them for recruiting all these great judges that we have this evening, too. So I'd like to thank Paulette Bruno Brooks and Leslie Ouellette in the Francis College of Engineering Dean's Office for their outstanding effort to put on this event. So Leslie, Paulette. I'd also like to thank Provost Joe Hartman, who's standing in the back of the room there, and everyone who has shown support to our students and the competition over the years. So now I'd like to thank our preliminary judges. And so we have here Andrew Amigo. Is Andrew still here? Oh, in the back there. Carol Devlin. Okay, so just kind of stand up or wave. I have this really bright light in my eyes, so it is not easy to see if someone responds. Mark Diamond did not make it this evening, correct? Okay. Bill Estes, right back there. Dave Janizik, back there in the corner. Bill Percibali. Okay. I saw him packing a bag with some cookies also, so maybe that's where he still is. John Ragwin. Okay, Mike Ryder. And Lee Chirac. Okay, I think they took the cookies and dinner and ran. So next, I'd like to welcome this evening's final round judges. First is Raja Abdulaziz, the co-founder and CEO at Invisaware Technologies. Next is Chad LaFrance, director at Texas Instruments and sponsor of our third place prize tonight. Then Chris McKenna, Boston office managing partner and intellectual property lawyer at Foley and Lardner, LLP. And Mark Saab, founding trustee of the Saab Family Foundation. And last but not least, Bhupan Shah, Vice President of Engineering at Acacia Communications. So, over the next hour, you're going to hear from 5 student teams. And each team, as I already said, is going to have 5 minutes to give their pitch, and then there'll be 5 minutes for Q&A. After the pitches, there'll be a 30-minute intermission while the judges deliberate. So I think there are going to be some snacks. Okay, something to keep you occupied for that 30 minutes. After that, the awards will be announced, and there'll be $2,500 to the first place team, $1,500 to the second place team, $1,000 to the third place team, and then there'll be a $500 award for the People's Choice Award. Please keep in mind that the first place winner will automatically advance into the DifferenceMaker preliminary pitch-off this spring for a chance to win a portion of $50,000. I wish luck to each of the teams this evening as they give their presentation. Now for the finalist teams and pitches. So in no specific order, here is the first team that is going to be giving their pitch this evening, and that team is Draw a Print. So will the Draw a Print team please come forward?
First year they didn't collect these, but I learned my lesson. They collect them now.
Oh, perfect. Probably just get this to Jonathan. Let's change the slides.
Right, same way we did that. Well, thank you, the Dean, for the introduction and the pleasant opportunity to be here on stage today. And we are the Draw a Print team. My name is Jonathan Aguilar. I am mechanical engineering major and alumni. And Jivo is missing, computer science graduate. He was on the floor, but unfortunately has some homework to take care of, and education is important, so we asked him to take care of that.
I'm Daniel Helmang. I'm a mechanical engineering senior.
I'm Rebecca. I'm a marketing and international business major.
My name is Phil Eskander, and I'm a computer science student.
My name's Teresa Foley, and I'm also studying computer science.
All right, so together we are the Draw a Print team, and we're focused on fixing the problem. And this problem that we're addressing is education and training for the additive manufacturing field, or 3D printing. The pain is that organizations or schools are spending a lot of money and resource trying to get people up to speed with 3D printing technology. So right now, SME is a company similar to us who are providing training services for a lot of companies. And so they pretty much provide certificate programs to help people with getting up to speed with 3D printing technology.
So for some opportunities for our company is that according to the market research, education is one of the fastest growing industry in the 3D printing market, and that many institutions are starting to set up labs for 3D printing also, like trying to do produce the prototypes.
And the $14 billion.
Yeah. So our market opportunity is around $14 billion US dollar from 2019 to 2024.
And these are some customer discovery that we did. So we conducted more than 100 interviews during this process. So from Carbon 3D, we have Connor saying that 3D printing is challenging, and mostly designing for 3D printing is a present challenge. And we also have John from Gala from Proto 3000 who mentioned that a lot of people are coming into the industry but don't know how to work a 3D printer, and so we're providing resources to help them get up to speed with the technology. And so, Phil, you want to take it?
Okay, yeah.
Phil.
Yeah, so
you got it.
the whole process sort of starts off with a canvas. We created a canvas for someone to draw a 2D print. And from there, using artificial intelligence, that 2D image is then rendered into a 3D model. And that 3D model can then either be submitted to a 3D printer that can 3D print whatever 3D structure that you created. Or if you wanted to have any adjustments, we also have a partnership with an additional company. And so over here, you're going to see that in picture A, you're going to see the drawing. In picture B, you're going to see that you can download the 2D print. Biggest reason why you'd want to download that 2D print is in the event that you want to make any similar adjustments that the 3D model wouldn't be able to do for you. And over here, you're going to see the artificial intelligence. What we did was our library grows day by day based upon how many people are using it. And so the more people use it and the bigger our library grows, the more accurate the 3D renderings will look.
And here is some results from the neural network training model. So the AI algorithm gets smarter. Like the more 2D design that we feed into the neural network, the smarter it gets in predicting the 3D models. And Daniel?
Since we're also focusing on education, and when you're designing a part, info are important to the structure and flexibility of that part. So we decided to include that feature where you can see the differences in infills and how it affects the part flexibility and strength.
So how it would work was once you drew a design, it'd be converted into a 3D print, and it starts off at 20%, but then the user can increase it up to 100%. There's a home button. It provides an exit warning, so if the user didn't mean to exit the program, they could click yes, no, or cancel.
And yeah, that's our revenue scheme, and this is our final prototype that you can use scanning the QR code, and we're ready for questions.
Yeah.
And if you want, you can actually do it from your phone right now if you're sitting down by scanning that QR code and try it out. Any questions?
Good. Yeah, I'll start by just giving you a chance to explain your revenue scheme a little bit more, how you intend to.
Thank you. I think
Capture
that goes
value.
to Teresa, our marketing expert. Rebecca, it's that.
Okay,
You're
so
right.
we have some premium options for the future sustainability. The first option is a 7-day free trial where companies and startups can try out for 7 days for free, so to see if they like the service that we provide. There's also another option which is $8 per month, and also another one is $80 per year, which is a little bit cheaper.
Okay. Any other questions?
So,
Yes.
so who are your target customers? What industry are you aiming?
It's a really good question. Our currently right now as we stand, our target audience or market is startups, engineers who have ideas. So they pretty much can use our tools to get up to speed with 3D printed technologies, so they can 3D print their prototypes a lot faster and immediately. And for this tool that facilitate that design for 3D printing service, we're really trying to bring this tool to K through 12, like 6th graders, so we can bring this as a resource. That's a good question.
So I have two questions here. One, what's the current state of the art of other options? So if we didn't have your solution here and the challenges, so I went out and I'm assuming with, the 3D printers are starting to get ubiquitous. They probably have some user interfaces to run them. What are they lacking that makes it hard for them that you're solving? And then the second one is on the when you go to print this, there's a whole bunch of different printers you could connect to. Have you figured out how you're going to manage, getting that recipe down to all those different printers? Is there challenges in working with different printers with your software?
No, absolutely. I think that's a really good point. And Daniel here actually designed a lot of the 3D models, and these 3D models are meant to be specifically for 3D printing. So our market niche is designed for 3D printing. So when we design these, and it gets matched like a heart shape, it gets matched with a 3D model that's a 3D model of a heart that can get 3D printed. And the value that we bring in is really, you get this 3D model instantly. And one of the values that we bring to schools and organizations is that they normally have to 3D print it at the school, so they spend a lot of money and resource, 3D printing material that could just be simulated through Daniel's 3D model simulations, like this one here. That's a really good point.
Good, thank you.
Hi, guys. So I definitely think from a startup owner perspective that 3D printing can be very challenging and very complex. I definitely see a need for the problem you're trying to solve. My question is, who are your competitors and how are you different? And I'll give you a quick short story. So my brother was 14 years old when we started Invisaware, and we had no prototyping experience and needed assistance with 3D printing. And he ended up using a tool called SketchUp in middle school and ended up 3D printing a circle with a square hole in the back. That allowed us to ultimately create the charms. So have you heard of SketchUp before? How is it different? Seems like a similar concept, which makes 3D printing for dummies like me and my business partner who don't know how to 3D print.
No, I think that's a really good story, background story. And when it comes to learning for the first time, 14 years old, we have sixth grader who, are a lot younger, and you're trying to teach them how to use these tools. And really they approach 3D printing tools like, we just created a partnership with, called Onshape, the founders of SolidWorks, where they bring in their tools into our 3D modeling system where you can modify the shape. But really this is a starting ground. So let's say you have an idea, so you draw that circle, and really you get that first interaction. Maybe in the future you decide to become an engineer and really take it to the next level. But this really brings out getting people up to speed with 3D printing.
Awesome.
When you say drawing, is it meant to be hands, just using your hands versus straight lines, like using PowerPoint or Visio? I can draw straight lines. You work with that? You work with freehand? Is that the issue?
Yep, so freehand, so as you can see here, these are freehand sketches,
Yeah.
and artificial intelligence looks at the drawing itself
I get it.
and then try to match it with a 3D model. So this is just a hand-free sketch. Yep.
So one suggestion is lead with that, because that was something that was kind of missing there, so that's a good point.
And our next team is Pengred.
Light is bright.
That light is very bright. Wow. Hi, everyone. I'm Ella. This is Ryan, Grace, and Danielle, and together we are Pengred, and we're working on fixing an EpiPen problem. So, I don't know how many people in this room are familiar with EpiPens, but the central idea of it is there is a needle in here. This is a trainer one that does not have a needle. But for real ones, there's a needle, and it goes inside of someone's leg when they're having an allergic reaction. So the problem that happens is with children, there's oftentimes that the needle gets embedded into the bone, which is painful, disgusting, and often requires hospitalization and surgery in order to remove. So this is not an ideal situation to have. So our solution here is focusing on making sure that these needles from the EpiPens do not get stuck in the bones.
we wanted to combat this problem by two ways. One, we want to reduce the force of the needle through internal components. And two, we want to make the length of the needle adjustable. So doing these, we can reduce the risk of the needle embedding itself into the bone of the patient. So the prototype we have right here, it involves a gear that you can use to raise and lower the needle as please. So what you would do is when you go to a doctor to apply for an epinephrine or EpiPen prescription, they would give you a recommendation for what size you would want to use. And that is how you would determine where you want the needle to be.
So the opportunity within this market is very large. Right now, it's pretty much run by Pfizer, who owns Mylan, and it's pretty much just a monopoly. So by us being able to go into this market, we would be able to combat with their prices and allow us to make money while having them lower their prices as well. Real life cases is that most people in the world know people who have allergies that require EpiPens. It's becoming more prevalent now with these younger people becoming allergic to more food like peanut butter and such things. And right now, the cost of a 2-pack of an EpiPen is $700, and the only other people who have tried to combat this issue is AviQ, who charges $5,000, and they just have a shorter needle and it's not adjustable.
As far as resources go for continuing this project, our current prototype is 3D printed, as we would like to continue with that as well. It worked well for this time. But we would like to, if we were to win this competition and take the money going forward, we'd like to get a medical professional consult and talk to them, as epinephrine is a prescription drug as well as auto injectors for it. We'd also like to get things like fake skin that's similar to use for suturing to test the puncture with and things like that.
Good evening. My name is Stephen Evangelos. I'm a third-year biomedical engineering student at University of Massachusetts Lowell. I'd really like to add a consistent 15 yards to my drive, but sometimes my hips, they just fall out.
Hi, my name is Mark Elman, and I'm a second-year biomedical engineering student at UMass Lowell. When I was 10 years old, I was diagnosed with scoliosis. Well, guess what, Jack? I'm ready for a better form of back pain management.
Our project is called proprioception and athletic...
Whoa, proprio what?
Oh, come on, man, proprioception.
Did you just say proprioception?
I know the Greek words proprioception.
Oh, you mean the total sensory feedback regarding limb and joint position in space?
That's the one, proprioception.
Oh, so you're talking about that spider sense there, eh, Peter Parker?
I guess I am, which means this presentation is really coming to you from your friendly neighborhood biomedical engineers. I'm Stephen.
And I'm Mark. Stephen, I sense a big problem in need of a big solution.
You said it, Mark. The problem that we're here to address is that the $81 billion sports performance market and $6.3 billion lower back pain markets in the United States collectively lack a gold standard assessment for core mobility and strength.
Whoa, that's big.
Our solution is the Hilarious Table, a lightweight, modular design equipped with MATLAB and Arduino telemetry that we coded here at the university. It's able to provide precision assessments of hip to lower back mobility with accuracy to 4 decimal places of 1 degree.
4 decimal places? That is laser precision.
Well, Mark, I think lasers go to 2 decimals. We're going to 4. You're on the right track.
Okay, Professor X.
Let's talk sports times.
Sports times behind the Hilarious Table is the kinematic sequence.
The kinematic sequence is a graphical representation of an individual's ability to transfer rotational energy from the lower half of their body to the upper half of their body efficiently. By optimizing the alignment, we can protect the lower back and maximize speed, because mindful motion matters.
Ah, proprioception.
Optimal alignment happens by sensing joint and limb positions, and the Hilarious Table teaches this using real-time biofeedback.
So what does it cost?
2018, we're talking about $250+ billion in lost revenue from the S&P 500 index alone. The National Academy of Sports Medicine has published research that proves that 80% of working Americans are going to end up in PT.
No. What does it cost you?
Me?
You said you wanted to add 15 yards to your drive.
Oh, okay, I get you. Summer 2017, the Harmon Golf and Fitness Club in Rockland, Massachusetts. We're working with 300 junior golfers aged 14 to 18. By the end of the summer, we're finding that students who can assess at less than 0.5 degrees on the Hilarious table are achieving speeds as high as 105 miles per hour at impact consistently. Players who are struggling to get inside of 3 degrees are barely scratching in the 90s.
Results. So how's Hilarious going to make money?
Our market segmentation strategy is pragmatic and ambitious. The sports performance market does not have a regulating body that says what can or cannot be sold as a piece of exercise equipment. However, we're here at the DifferenceMaker because we're ready to pursue the FDA-regulated markets of orthopedic therapy and physical therapy. Let me be crystal clear. Our customer is not the person with the back injury or the individual who wants to hit the long ball. Our target customer is the industry-accredited professional who provides services to those individuals.
All right, so let's get down to business.
The barrier to entry for the sports performance market is low. The barrier to entry for the lower back pain, physical therapy, and orthopedic therapy markets is slightly higher due to FDA regulation and the required clinical trials for the FDA. But with your help, we're going to be able to build 2 additional prototypes and hire 4 additional research assistants. That means we'll be able to operate 3 tables, autonomously collecting data to satisfy each of our target markets: sports performance, lower back pain, and some type of clinical PT or OT application. We're currently exploring options with the VA hospital in Jamaica Plain, Boston, to work on gait analysis and proprioception with wounded veterans. Next semester, though, with our current resources, we will be operating an IRB-approved research study under the guidance of our research mentor, Dr. Yanfin Lee, with an emphasis on sports performance using the Hilarious table here at UMass Lowell. My name is Stephen Evangelos, and I want 15 more yards on my drive.
My name is Mark Elman. I'm ready for a better form of back pain management.
It's time for a new twist on core training. Thank you very much for your polite attention.
At this time, we'll be happy to take questions and comments.
Well, you guys are ready for Shark Tank, that's for sure, so I'm looking forward to that, okay? Nice job. So I look at that contraption, like, how long does it take to assess somebody on that? Because I'm kind of afraid to even get on it. Like, how hard or easy is it to use that? And what does that cost? Well, answer the first question, though.
It
Like,
takes 2 minutes to assess somebody on it.
wow.
It takes 1 minute to correct, and it's fast and it's efficient.
Wow, nice.
How much does it cost to build? What you're looking at is prototype number 7. Prototype number 6 was the silver one that you saw in the image there, and that's the one we used at Harmon. It has the same functionality as this one. That one cost $3,200 in materials alone to build. We've distilled it down to $1,250. Every piece of metal in this device is sourced from the United States, from Indiana. And we have an entirely vertically integrated process from raw materials to deliver a product. The device is currently patent pending, and we've been working with exercise physiologist Mr. Jim Marchetti. If you could stand up, please. Give him a hand, please. The biomechanics expert to help us refine the movement on this.
So one more question, and I'll stop talking, I hope. Because biofeedback, if I'm on that, you say adjust it for me, as a user do I feel something? Like, how do I know that I'm getting fixed?
What we're looking to define is what's real versus what is perceived. We want to know that when you decide that you're at a position like this, are you really?
Right.
Like I said, 4 decimal places of 1 degree. Wow, excessive. No. Nerve impingements, very small units. These decimal places matter. And we can teach folks how to stop having the back injury on the 12th hole.
And that's where the mind comes in, where if I'm thinking I'm straight aligned, like on a golf swing.
You've read the articles, you've seen it on television, the mind-body connection,
Yeah.
the muscle connection, the muscle memory. It's motor learning. Proprioception is the foundation of motor learning because you're learning how to put your joints in the right position without having to be told. The biofeedback comes from a monitor that gets plugged into an Arduino control system on the bottom, so we can feed numbers. We can feed it an object that tilts. We can feed an old-looking carpenter's level. But for the junior players who assess to the left and we need them to the right, I love Mario Kart, and I love to steer it with my hips on a track that has more right turns than left ones. They think they're playing a game, but we're adding yards to their golf and protecting their backs.
So it costs you $1,200 to make it. How much do you sell it for or how much do you plan to sell it for?
application. However, as you can see, the device is modular. It's very easy to add different pieces to this to make it more accommodating for clinical applications, neurological disorders. I have a cast on it, and I don't want to curb my entire training. Can we still work on the table? Yes, we can. It keeps you in the game.
And how long does it take to build one of these? How do you plan to scale?
For the sake of scaling, we're interested in pursuing not having to use 14 bolts to make a corner and switch it to maybe some type of softer steel, some type of welding. For the scaling, we could produce 3 of these in a day with the 3-person team we're operating with right now. But once we have more of them, we're going to be able to collect more data. We're going to be able to publish more data, and that hedges against marketing because nothing says this thing works like a peer-reviewed journal article.
Last question. How have you guys been funding yourselves to date?
We have taken one loan from a private investor in order to acquire intellectual property protection for a rectangular frame housing a longitudinal axis with 2 rotating platforms, plus or minus 10 on the top, plus or minus 45 on the bottom. We paid that loan back in full. We're currently operating with 0 debt, and we would like to come as hard as we can to this competition so we can continue to expand.
So this high school golf team that you studied, was that purely an assessment or was there a correction involved as well?
That was assessments. We had the entire summer to work with these kids. The assessments at the beginning were -12, +7. We're not even in the ballpark of where we wanted to be. But if we have a -12 and your body wants to be over here, we can make that problem really, really focused and exacerbated so that you have to fight back in the other direction. You're not working with pounds.
No, sorry, my question wasn't that. So you didn't do any correction, right? You just assessed, is that right?
We assessed and we did correction. Now, mind you,
Yeah.
at Harmon, that was prototype 6, and we were not operating with IRB criteria for objective feedbacks and everything. In the research environment, you get an assessment, you leave, we graph your data at the end of 6 weeks. But at Harmon, we were doing the corrective procedure because we wanted to have these kids in good hand. Thank you all very much. Thank you.
Pauses so they can come back here and get their masks. Yeah. Don't want you to break any rules here. So, fourth, but not necessarily in that order, prosthetic hand for steering.
Hello?
Sorry, I gotta take a second to calm down.
Take your time.
All right. I'm ready. So my name is Tim England. The project I'm working on is prosthetic hand for steering. It's there. Oh, perfect. So the need statement is to allow farmers who have suffered hand or arm amputation to comfortably operate a motor vehicle steering wheel again with a fully mechanical hand attachment. So the problem is that, the target audience is farmers. So the problem is that there are currently prosthetic hands on the market, but most of them with movable digits require electricity. So farmers spend around 8 hours a day in the field. They won't have access to electricity. And the farming environment, it's wet,
they're exposed to pesticide, chemicals, and there's dirt. So most prosthetics on the market are very expensive, but they also wear and they break down very fast. If its life was like maybe 5 years operational, it'd probably be like 2.5. So most farmers choose to use this thing. It's called a cable-operated work hook. So they choose to use this because it's fully mechanical. But the problem with this device is that there's only one angle, and for steering, it's very difficult. They'd be steering like this. The work hook has an open, closed clamp, but steering a wheel is very difficult. So the opportunity is, it's a little hard to get the statistics, but from what I found, there's around 2.6 million farmers in the United States. And for the incidence of accidents, 1 in 10 farmers will have to suffer an amputation. But out of 1 of 10, some of the amputations are for fingers, so then it becomes 1 out of every 200 farmers would suffer a major limb amputation, which would be either your arm or the leg. So that counts for around 13,000 farmers. So it's a niche marketplace, but as you can see, there are farmers who suffer. And you can see in this photo right here, he's using one of the cable-operated prosthetic hand work hook, and he needs 2 of them. So the solution that we developed is that it's a 2-piece, fully mechanical device, no electricity required. So the first piece would attach to a steering wheel. This is a very generalized steering wheel. There'd be probably a Velcro strap that goes around. And then the second piece is the hand attachment. So this hand attachment would go back, and most farmers will have this device if they choose to use it, the cable operated. So you would remove the work hook, and then you would insert the hand attachment into it. So there would be a screw here. So with this device, you'd be steering this way instead of steering like this, because you would insert this knob into that piece. So this is a CAD drawing, and that's just a little bit of animation of how it would click together. So the resources that I need, what the team needs, is that currently I'm the only one who will be taking this project ahead. Hopefully I might be able to find some other people to help me with this project. So we're currently in the prototyping stages, which means for the prototype that I had designed, we used 3D printing. So unfortunately, we use the Makerspace's 3D printer. However, since I'm a senior in biomedical engineering, I'll be graduating this semester. So what I would need is either access to a 3D printer, or I'll have to purchase 3D printer, and we'd use the funding to make the materials and make more iterations of the prototype. There are several parts of the prototype that could be improved. One of them is that for this angle, I hope to either find an optimal angle, or it can be on a rotational orb, so that the farmers can have easier steering. Another thing is, for this piece, the wheel attachment, there will be memory foam and a layer of rubber that's to increase friction, so it can grip to the wheel, and we'll need a strap for it. But it'll have to go through multiple iterations for prototyping, which means we'll need access to a 3D printer. And thank you for watching.
No, thank you. Great presentation. How'd that become your solo passion project? Because I'm listening, it's a very interesting, unique space, and it's a niche space. So I learned a lot through it, because I didn't know that was such a problem and the high incident rate for that. So how did you kind of follow up on this?
So I've been taking medical device design with Professor Looney, and for one of our assignment was to research different medical devices that we can make. So I was just doing a bunch of general research, and then I came upon the topic of farmers who lose their arm, and then I read an article. This farmer was working late at night. He was alone. It was actually I believe it was this interview that I was reading, and he was operating his corn, it's like corn harvester.
Sure.
And so there's rotating blades, and something got stuck in it, and he was tired, and he stuck his hand in. It got caught, and then his second hand got caught. So, and then he was there. There's several articles, and they're struggling with driving their tractor. So I was like, it looks like the solution would be relatively simple. So I was like, let me try and design something.
Thank you for sharing that.
Thank you.
There must be other opportunities as well, not just farmers, I would think,
So-
if you look at that.
Yes. So, this device, I chose farmers for the base target audience because of their work environment. But this device can work with anyone who has lost their arm or hand. So the audience, I only focused on farmers, but anyone with who needs a prosthetic hand can use this as a very cheap solution. Yeah.
Is your goal to commercialize a product here and sell it, or?
So, with the limited funding, so it's just personal funding at the moment. With the limited funding, what I think is most viable is there are communities online and forums that share 3D CAD drawings, computer-assisted drawings for like SolidWorks, which for 3D printing. So potentially, if I could even just, I'd have to make sure it's a class 1 medical device. I'd have to make sure it complies with FDA regulations, but if I could just distribute the design so people can print it, or I can also manufacture however many I need to distribute it. So I'm just hoping that whoever needs this device gets it into their hand. The material, plastic, is very cheap. So if I were to be able to market the device, I would hope that it would only be $60 because it's just plastic. Maybe steel if I use better materials.
So this is fascinating. I share Chris's comments. I learned a lot here. You mentioned at the beginning, there's a real opportunity to bring other team members in and flesh this out to a lot more as well. So it's exciting to me. So thank you.
Thank you. Any more questions? Thank you for asking all the questions.
So my teammates are picking up a couple things. But thank you, everyone, for waiting this long for sitting. And we look forward to presenting our idea to you all.
Anything nice?
So right now, what we're placing in front of the judges is our current working prototype and a quick QR code where you can watch a video of the prototype working, since it has to get plugged into a monitor. So, good evening. Thank you everyone again for being here. My name is Victoria Williams. This is Amy Russell and Ethan Block, and we are 3 biomedical engineering students who are interested in innovating emergency care. So the origin of Pendrin, which is our company, came from a bad emergency room experience. I think we all have a bad emergency room experience. We all have long waiting times in the emergency room. It used to be in Massachusetts on average 2 hours and 11 minutes, but currently during COVID times, the national average is up to 12 hours. During this time, the emergency room is where you go when you know something is wrong, but you have to wait in order to see a doctor, and the doctor will diagnose you and help you with this problem. This 12 hours is a very long time. Something bad could happen to you, and there's nothing currently triage is the process where the nurse is evaluating how serious an illness is. My dad was minimizing his pain, as dads do, and unable to clearly communicate what was wrong, considering he doesn't have a medical background. So we end up waiting an hour in the emergency room. Once we are admitted and speak to the doctor, my father is diagnosed with a blood clot in his lungs, which is a very dangerous situation to be in. That blood clot at any point could have branched off and caused stroke and aneurysm. So that hour waiting in the emergency room could have been fatal to my father. So reflecting on this situation, I realize there's a huge need for the market, for some sort of medical device that monitors patients who knows that something is wrong and is in the waiting room during that post-triage but pre-admittance time period. And this is where our device comes in. So our device is a modern device. It has a rechargeable and reusable wrist piece and a one-time use finger sensor. So the device itself will measure SpO2, ECG, heart rate, blood pressure, and temperature. Also the location of the person. We specifically included ECG and SpO2 because SpO2 will tell us if someone's having an asthma attack or having complications due to COVID. And with the ECG, we included that one because it will tell you if they're having a heart attack or not. We included location also because if a person were to walk off, say, to the bathroom or someplace else, if they pass out there, the nurses will be able to see that it occurred and then find them quickly. So all the information will be relayed to the nurse's triage station, where it will alert them if there are any abnormal or very large spikes in the vitals, so they may react quickly. In terms of integration of our device, we plan to make it very similar to devices they are used and programs that they are used, so it should be easy for them to adjust with it. We hope that the product will help with a faster diagnosis along with a faster reaction time if someone has an issue. Also, a peace of mind to the patients themselves and their loved ones, because currently, because of COVID, when you go to hospital, you have to go in alone because just regulations. And if you pass out, there's no one there to make sure that you get noticed. You could be sitting there just in pain, but you can't speak up.
So as Amy said, and as you can see in the prototype, it's a rechargeable, reusable wristband and a disposable finger sensor. And we chose to go with the two products because it will follow our razor blade sales method, selling the wristband as the razor with a 40% profit margin and the finger sensor as a razor blade, 87% profit margin. And with over 200 million Americans going to the emergency department every single year, there's a massive market for this product. And in terms of competition, there's currently no competition for this product. In that post-triage, pre-admittance into the emergency room, there is no monitoring of patients. In part, probably for that reason is because the current model on the market is clunky and it's wired. Each one needs an individual screen so you can see the data coming from it. But Tendrin will be easily accessible, wireless, and link all patients to one screen. If we were to win today, the money would be going towards developing the product and seeing that it can get to market quickly. So, thank you.
So why won't my iWatch solve this problem?
So the current Apple Watches actually do have a rough monitor of heart rate and things like that, but they are not at all up to grade to medical standard, and they are also limited in what they do monitor. So that is a nice thing for a personal patient to have. However, this will be more accurate with the data that it collects, and it will be sending the information straight to the triage nursing station, so the nurse will be able to act regarding to this patient situation.
So is this a working prototype?
Yes, it is. If you scan the QR code, you can see it working.
Okay.
It's not linked into the presentation.
And how does it communicate with the nurses' stations? The Bluetooth or?
Yeah, it'll be some Bluetooth or Wi-Fi going from the band to the monitor up front.
And currently there are wires, obviously, because it is our first prototype, and there will be an RFID connected to the bracelet in the center from the finger sensor to the bracelet. The bracelet will have Bluetooth that sends signals.
Have you talked to any emergency room providers to see if they will accept something like this? What would they think?
We've discussed, our professor actually has experience in healthcare, and she has verified that this is a need to happen. We have still yet to talk to hospitals specifically. We were hoping, in this DifferenceMaker competition is a great way to connect with people who have those, that knowledge base.
So I have a question about the use. So I show up at the hospital, they're checking me in. Do you see like someone at the station giving it to me? And is there any difficulty, like someone put it on? Do they have to put it on me? I put it on myself? How do they match me to the watch, right? Have you figured that part out in terms of
So when
deployment?
you go into the emergency room, your triage, they ask you your name, you give them your information, and they ask you, like, what are your symptoms? What are you feeling today? And during that time, you get a bracelet already with your name and information. And this would be another bracelet applied, linked to you with your other bracelet and whatnot. And the sensor and the bracelet will be put on at the front desk when you walk in.
So it's really put on and then?
Yep, and then
I
you
don't
can go
have
to your
anything.
seat
Yeah,
and
gotcha.
you're being monitored for your time waiting.
Now, how do your loved ones get access to this information?
So the information will only be up front available for the triage nurse. I think if you have the information right in front of you, someone might look at that, it could make them nervous, like seeing their own vitals could make them nervous and cause a reaction you don't want.
I'm gonna buy a nice piece of jewelry.
Can make these a necklace form or fitness band form. Like the way Chris thinks.
Yeah, I know where you're going with that.
So that integration, the software on the Bluetooth, that's also part of the prototype. Have you done any work with the software?
The first
Integration?
software development would first make it HIPAA compliant, so data could be saved and whatnot, but it would be integrated straight into hospital technology. And nurses already have a lot to look at, so it would really only present itself if there was a problem, if someone was trending in the wrong direction.
But we do have to do more research into specifically how to integrate that software. In that, hopefully, some of the funds we would use to work with, like maybe someone more well-versed in computer science and has with that background.
So some of the things you mentioned, like blood pressure, that wouldn't measure your blood pressure, that device, would it?
That device does measure blood pressure.
It does?
Yes.
It does.
Given, this one currently, given parameters of a blood pressure cuff reading, it will be able to detect changes in your blood pressure.
Okay.
Yeah.
But it doesn't actually squeeze?
No, it doesn't actually
Doesn't do
squeeze.
that. So but it has a way of calculating the blood pressure from?
Yes.
Okay.
It's similar to, there are pulse oximeters that you get, when you actually are admitted into the hospital, that there's a very clunky device that is put on your finger that records this information as well. So you'd be using that same technology, but it would be wireless and it would be more accessible for, patients who are not admitted yet.
Before time runs out, cost? Do you figure out cost?
We estimated the band, we'd sell the band around $50 and each sensor between $7 and $10. That's based off market research of what's currently being sold.
How much money do you think it will take to commercialize this technology, so to bring the product to market or to fully develop it?
I think the real cost would come in the 510K. We estimated we would do a 510K to get FDA approval. Not sure on the specific cost of that, but that's where the money would be going to as well.
But considering the ER has such a large client base with 200 million people every single year going to the ER, is that finger sensor, we have like an 87% profit margin with that, that's where we'll get the majority of our profit.
Thank you.
Nice job, thank you.
Thank you. Appreciate it.
So let's thank all of our teams one more time. So, in addition to the 3 prizes that will be awarded to 3 of these 5 teams that just presented, there's also the People's Choice Award. Does everybody know, Paulette, how they go about doing that voting?
The People's Choice Award, yes, that happens
Okay? Okay. So there'll be that opportunity. So I'm now going to excuse the judges to deliberate. And while they're doing that, you can enjoy some beverages and some snacks. And we'll be back in about 30 minutes. It's now my honor to announce the winners. And I'm going to start with third place, then we'll go second, first, and then we'll go to the People's Choice Award. So third place goes to Tengrid. I love giving out these really big checks. Sorry. What's the 3D print? Is that over? Everybody get their hands on this check. Yeah. Congratulations. Don't try to deposit that under. Second place is Tendrin. Actually, take your glasses off for the picture. Sure. Yeah. That's great. And now for the drum roll. And in first place is proprioception.
Mark, get in the middle here. All right.
Very good.
We'll get you guys to take a step forward.
Thank you all very much. Thank you so much. You earned it, buddy. That's awesome. Great for you. All right.
And I would like to say one thing the judges are adding just an honor, let's put it that way. So prosthetic hand for steering gets an honorable mention. I apologize, I don't have a certificate for that. And then for the People's Choice Award, Tendrin, please come back up here.
Different check. Different check.
Same order, different check. So, thank you to our judges once again. Thank you for everybody who participated in tonight's event and for those who came to watch what was happening here this evening. It was a lot of fun. Stay well, stay safe. We're done.